everyone, I'm going to walk you through circuit analysis example number 3. So I've got my original circuit right here. And the first thing that I'm going to do, just to make sure I understand what's going on in the circuit, is just identify all the different pathways for the current to travel from the positive to the negative terminal of the battery. So I see two possible pathways. One is going up through this 3 ohm resistor, and then at this junction going down through the 18 ohm resistor, and then back over to the battery. And another pathway that I see is again going up, again going through the 3 ohm resistor, but then going right at the junction through the 9 ohm resistor, and then down and back over to the negative terminal of the battery. So that shows me that there is one place where my current splits, and that's right here after the 3 ohm resistor. And then those two current pathways come back together again at this junction right here. So I'm going to combine these two branches in parallel first to get my equivalent resistance. And since I only have one resistor on each of these branches, I can just go ahead and immediately combine them in parallel. So 1 over the equivalent resistance is going to be equal to 1 over 9 ohms plus 1 over 18 ohms. Or in other words, the equivalent resistance is going to be equal to 1 over 9 plus 1 over 18 to the negative 1 power, which should give me 6 ohms. So from there, I redraw my circuit. I've kind of already taken a shortcut there. And these two parallel branches get replaced by a single 6 ohm resistor. So now I'm getting closer. I still have 2 resistors here. They're connected in series because all of the current that goes through this 3 ohm resistor would also go through this 6 ohm resistor. So I can go ahead and add those two up in series. So then combining those two, the equivalent resistance is going to be equal to 3 ohms plus 6 ohms, which is equal to 9 ohms. So then this whole circuit here can be simplified down to a single 9 ohm resistor connected with a 9 volt battery. All right, so that's good. And now that I'm down to a single resistor, I know that the entire voltage drop of the battery would have to occur over this resistor because the sum of the voltage drops around any path around the circuit has to be equal to the voltage of my battery. So I know that my voltage here is going to have to be 9 volts. And then I can solve for my current using Ohm's law. V equals IR, or in other words, I equals V over R. So the voltage for this resistor is 9 volts divided by the resistance, which is 9 ohms. 9 divided by 9, that's 1 ampere. And this tells me the total current for my entire circuit. So I can actually go back up to the beginning at this point, and right here where I have my total current drawn from the battery, I can fill in this 1 amp right there. Okay, now I have completely analyzed this version of the circuit, so I'm ready to go back one step and go to the previous version of the circuit. So I go from here to here, and what happens is I've split my 9 ohm resistor back into 2 resistors that are in series with each other. Now since these have been split into series, I know that my current has to stay the same, that my total current running through each of these still has to be 1 ampere. So I'm going to go ahead and just immediately copy that over from here. So this 1 ampere gets copied for both of these resistors because all I did was I took this resistor and split it in series, and in series the current stays the same. So then at this point I need to solve for the voltage of each of these resistors, which I can do using Ohm's law. Ohm's law is usually the answer to any question you have in circuit analysis. So to get the voltage here, I just need to multiply the current, which is 1 amp, times the resistance of each resistor, which in this case is 3 ohms. 1 amp times 3 ohms, that gives me 3 volts. Then over here, I've got a current of 1 amp and a resistance of 6 ohms, which gives me a voltage of 6 volts. So now I've thoroughly analyzed this version of the circuit, so now I can go back one more step to the beginning. Now this 3 ohm resistor doesn't change from this point to this point, so I can just copy these values straight up to the original circuit. So 3 volts for the voltage drop across the 3 ohm resistor, and a current of 1 ampere will flow through it. But this 6 ohm resistor is getting split it's getting split into an 18 ohm resistor and a 9 ohm resistor that are in parallel with each other. And when I split a resistor in parallel, I know the voltage has to remain the same. So this 6 volts is going to transfer up to each of these resistors that I split this one into because I split it in parallel. All right. So now I've got the voltage and the resistance for each of these components, so I can once again use Ohm's law, I equals V over R down here, to figure out what the current is through each of these pathways. So right here, current's going to be equal to the 6 volts across this resistor divided by 18 ohms, so that's going to give me 1/3 of an amp, 0.33 amps. And then over here, I've got a voltage of 6 volts divided by 9 ohms of resistance, which is 2/3, or I'll just round to 0.67 amps. So now I'm done. I've analyzed for my original circuit the voltage and the current for every single resistor. But just to make sure that I did it right, because there were lots of places where something could have gone wrong, I'm going to check my work using the loop rule and the junction rule. So the loop rule says that for any complete pathway, from the positive to the negative terminal of the battery, the voltages of all of the resistors that the current passes through should add up to the voltage of the battery. So we're looking for a total voltage of 9 volts for any complete pathway around the circuit. So if it goes through this 3 ohm resistor and then down through this 18 ohm resistor, then that would be a voltage of 3 volts here, plus 6 volts here. 3 plus 6 gives me the 9 volts of my battery, so that's good. I'm going to check my other loop around the circuit. So for any current that goes to the right at this junction instead, it's going to lose 3 volts here at the 3 ohm resistor, and then another 6 volts here at the 9 ohm resistor. 3 plus 6, that's still equal to 9 volts. So I'm good on the loop rule. Then there's the junction rule, which says that the current going into a junction has to be equal to the total current coming out of the junction. So if I consider this junction right here, I go to the previous resistor before I reach that junction, I see that the current running through this branch right here is 1 amp. So I've got 1 amp flowing in. And then the current splits. And it splits 2 different ways. I've got some going to the right, and if I look at this resistor, I can see how much current that is. That's 0.67 amps. So you're 0.67. And the current that goes down through the 18 ohm resistor, I can see that current is 0.33 amps. So 1 amp that's going in is equal to 0.67 plus 0.33 amps going out. So I have an equal amount of current going into my junction as I have in total coming out of my junction. So I am good to go. I have analyzed the circuit correctly.